Good morning, good afternoon, or good evening, Honor Statistics. Thanks for joining me online here on YouTube. We're going to start with Chapter 7 in our textbook today, and we are going to talk about the idea of a confidence interval. So today's objectives are to interpret a confidence interval in context, and also to determine something called the point estimate, and also the margin of error from a confidence interval. All right, so to think of what exactly a confidence interval is, usually starts with a question that we want to figure out. Now, for instance, we may want to know, or a company may want to know, like how long does a battery last on the newest iPhone on average? And oftentimes what you will see is sometimes we cannot get a single answer, and we often report an answer as a range of values. So let's say the interval for this question is 10 to 12 hours. You may see a confidence interval reported in this format. We may want to know a question like this: what proportion of college undergraduates attended all of their classes last week? That would be a proportion, and maybe that might be written out in this form: 0.72 to 0.80. That would be another example of a confidence interval. Maybe a company wants to know this question, or a consumer wants to know: how much does the weight of a quarter-pound hamburger at a fast food restaurant vary after cooking? So confidence interval usually starts with some kind of a question, typically about a proportion or a mean that we want to know, and we develop this interval. You might see confidence intervals during election season, and oftentimes they'll give you some type of percentage. So here there's all kinds of polls on the general election and who you would vote for. And you'll notice there's always a margin of error, or there should be a margin of error given at the bottom of whatever poll you're looking at. And that gives you a range of outcomes. So on this first poll here, so let's look at the one for President Trump, this 39% value. With their margin of error of plus or minus 3 percentage points, we're looking at this value turning into 36. Let's make that 0.36 all the way to 0.42. And we'll talk about what that margin of error exactly means, but a good poll should let you know what that is, and you have this range of values here that are plausible. Okay, so moving on. All right, so I'm going to go ahead and read some of these, read this definition for you, so make sure you pause the video and write it down if you need to. So a confidence interval gives an interval of plausible values for a parameter based on sample data. So again, parameters are things about populations. Usually it's mu or p is what we are most concerned about, especially in this class. And we want this interval of values that are plausible. So down here it says plausible does not mean the same thing as possible. Plausible means that we shouldn't be surprised if any of the values in the interval is equal to the value of the parameter. We'll talk more about that as we move on through the lesson. All right, so here's a little cartoon joke that I'll refer back to as we go on here, but here an interval is given of 40 below and 200 above. And again, I will come back and talk more about this cartoon because it illustrates a concept of confidence level, which we'll talk about actually in the next chapter, but we will refer back to this later on. Okay, so the confidence level, and again, we'll cover this more in detail in Chapter 7 too, gives the long-run success rate of confidence intervals calculated with C% confidence. That is, in C% of all possible samples, the interval computed from the sample data will capture the true parameter value. Again, tomorrow we'll get a lot more in detail with that, but the most typical confidence level is 95%. All right, so just keep that in mind. That's the one that we use most often. But for now, don't worry about that too much. We'll get a lot more in detail in chapter 7 too about what a confidence level is. Now, I do want you to copy this down as well here. The interpretation of a confidence interval. So the sentence frame is this down here. Okay, you'll notice that in the next few problems here. To interpret a C% confidence interval for an unknown parameter, we say we are blank % confident that the interval from blank to blank captures the parameter in context. So I'll give you a couple of examples of how you're going to use that sentence frame in just a moment. All right, so let's try this out here. A large company is concerned that many of its employees are in poor physical condition, which can lead to decreased productivity. To determine how many steps each employee takes per day on average, the company provides a Fitbit to 50 randomly selected employees to use for one 24-hour period. After collecting the data, the company's statistician reports a 95% confidence interval. So this is called a C level, the confidence level. And the 95% confidence interval is 4,547 steps to 8,473 steps. So all we're going to do is interpret this confidence interval using the frame on the previous slide. So we are 95% confident that the interval from blank to blank, so those blanks are these two values, and we should put the unit here, so I should add the word steps here. 4,547 to 8,473 steps captures the true mean number of steps taken per day for all employees at this company. That word mean may sometimes be the word proportion, depending on what type of data you're given. All right, and in the next example, you're going to see just that. Sometimes we capture a true mean, and sometimes we capture a true proportion. Okay, so we're going to read through this, and then I want you to pause the video and try to write the interpretation on your own. So, a recent Gallup poll asked a random sample of 1,010 Americans to respond to the statement, if the U.S. fails to develop a more talented workforce, it will fall behind other countries. The 95% confidence interval for the proportion who would respond strongly agree or agree is 0.74 to 0.82. Interpret this confidence interval. So like I said, please pause the video and give it a shot on your own and restart it when you're ready. All right, so here we are 95% confident that the interval from 0.74 to 0.82 captures the true proportion. Since this data is in proportion form, it's a percentage, we're going to write the word true proportion. Who would respond strongly agree or agree? There are no units next to these values as they are proportions. So as you saw in the other example, we said steps, but here it's just a proportion, no units are needed, just those two values that were mentioned. All right, so now we're going to talk a little bit about how to get this confidence interval and how it's structured and how it's created. So there are two components. There is something called a point estimate, and think of this as your midpoint. And you'll notice some similarities to the midpoint formula in geometry, which I'll mention. So you have a point estimate, which is like the midpoint of your interval, and then you have a margin of error that accounts only for sampling variability. Okay, and again, we'll talk more about that later on, but margin of error doesn't account for a poorly collected sample. All it's doing is taking into account sampling variability. And here is a point estimate plus or minus margin of error. This is that structure of a confidence interval, and this is a visual example down here of what that looks like on a number line. Your point estimate's right here in the middle, and you've got this margin of error that's equally spaced out on both sides. All right, so here Some more notes about the point estimate, and it just says it's our best guess for the value of the parameter, and it is often unlikely to be correct because of all the variability that's just, that occurs with sampling. So down here, again, more definitions on point estimate and margin of error, but I'm going to speed up a little bit because I've got 2 more examples that I want to cover with you. So just pause the video and write these definitions down if you need some more time. Okay, so in this example, we're going to go back to the Fitbit example here. So we learned that 95% confidence interval for the true mean number of steps taken per day for all employees at this large company was 4,547 to 8,473 steps. We're going to calculate the point estimate and the margin of error that was used to create this confidence interval. All right, so again, think of these 2 values as points on a number line, and we want to find that middle value, like what is the midpoint between those 2 values. So on the next slide, you'll see, let's call the first value A, and let's call the second value B. So I'm going to add those endpoints of this interval, A plus B, and just divide that by 2. Again, think of the midpoint formula in geometry where you add your endpoints and divide by 2. And we get a value or a point estimate of 6,510 steps. Now, for the margin of error, all you need to do is take this value. I usually just subtract the larger value from the point estimate. So here, I take that value of B from above, 8,473 minus 6,510, and we get our margin of error, which is 1,963. You can also take the point estimate and subtract it from the lower value. You'll still get 1,963. Just keep that margin of error positive. We do add a plus or minus in front of that number, but the margin of error itself is a positive number, 1,963. All right, so on the previous pair share, you learned that the 95% confidence interval for the true proportion of all Americans who would respond strongly agree to that previous poll is 0.74 to 0.82. I want you guys to calculate the point estimate and margin of error used to create that confidence interval. Please pause the video, try it out, check back when you're done. All right, so again, add up the endpoints of that interval, 0.74 plus 0.82. That gives you about 1.56. When you divide that by 2, you get 0.78. That's your point estimate. Again, I usually like to take the larger value of the interval and then subtract it from that point estimate, and you get 0.04. So that's our margin of error. So in a poll, you might see it written as 78% with a margin of error of plus or minus 4 percentage points. And that's usually how it's reported in all the election polling data. You'll see it written kind of in this format. But keep in mind, this is how we look at it when we're creating the confidence interval for a proportion in our stats class. All right, let's try this example here really quickly. Just wanted to give you guys one more. So try it out, read through it on your own because I am running out of time, and then we'll go over the solutions really quickly on the next few slides. All right, so interpreting this confidence interval is we are 95% confident that the interval from 0.48 to 0.54 captures a true proportion of all registered voters who favor candidate A in the election. For part B, the point estimate, remember, add those endpoints up, divide by 2, get 0.51. Take the larger value, subtract it from the point estimate, and get 0.03. The last question is very interesting, so I wanted to take some time with that. So it says, can the reporter claim that the majority of registered voters vote for candidate A? Now, the confidence interval, any number in that interval is plausible, which means that 0.48 and 0.49 are just as plausible as any of the others. Therefore, The interval does not give you evidence because these are not possible, but plausible values.